Before we explore GPU instancing in Unity, we need to generate some GPU data to instance. Let us create a buffer of positions. And I already have an empty scene here with a directional light in Unity 2021.2.0b6. And I think that this will mostly work in anything above 2021.2. I have a folder called tutorials, another folder called O1 position buffer, and I have saved my scene in here. Now create a script, and I will call it position buffer generator. And open it up. Then I will paste in some code. Let us review this code. I have a constant of max points, and because we're creating a buffer of positions, this will be the maximum length of the buffer. I also have a public field here that allows me to control the number of points. And then here I have some parameters that we'll use to affect the points, mostly related to sine waves. We will also use colors, and here are some parameters to affect the color. Next, I have two graphics buffers. First is positions buffer, second is colors buffer. Why are we using graphics buffers instead of compute buffers? Unity's VFX graph currently wants a graphics buffer as the input, and you can read more about the extra features that graphics buffers add on top of compute buffers, but for the most part, you can think of them as a compute buffer. Finally, we have a game object reference that we will use to test. Our start function is quite simple. We initialize the two graphics buffers. You'll note that when initializing a graphics buffer, you need to put the type. This is sort of like the compute buffer type. We are just going to use the normal structured buffer type. We then, as you would in a compute buffer, pass in the count and the stride. Positions is 3 because it is a float 3. Colors is 4 because it is RGBA. And then every frame we call update. Note that because we are going to later inherit from this class, this is protected virtual void update. And I'm certainly not an expert in C#. This is just one way that I found of doing this. Our goal in the update function is to populate a buffer of positions. So we create two arrays, both of length and points, and then for each point, we generate it. The position is generated using an x position of I mod the mod field that we pass in here. And the y position is generated by multiplying the amplitude times the sine of the index over a frequency input, and then we offset it by the frame count divided by a speed input. If you aren't familiar with these parameters to sine, I encourage you to play around with them to get an intuitive understanding. And then I have a simple function to determine color. Now that we have created these arrays on the CPU, we need to store them in GPU memory. So we will call positions b.setDataPositions. So we're sending this array over to the GPU. Then we do the same with colors. In order to debug this, we will read this back each frame by creating a new array and then calling getData on the positions buffer. And then we will set the position of the test object to be the first value in that buffer. So positions 0. Finally, we need to release the buffers on destroy. To verify that this works, let's move over to Unity. And after a bit of compilation, we will create an empty game object that we will call code, and then drag in our position buffer generator. We now need a test object. Let us use a cube, and then we can select that cube. And in theory, we should have a cube that goes up and down according to our parameters here. We have no camera right now. And there it is. For convenience, let's go ahead and make a camera. And we can set it to the position of our scene view by using GameObject align with view. And now when we click play, we will not have to switch over to the scene view. There we go. So what we've accomplished here is we have a CPU side function that is populating a GPU buffer of positions. And in the next videos, we will look at different ways to render those positions using GPU instancing.